There we go. And now I'm going to share screen. All right. So we're going to go through this. Should be reviewed for you. Hopefully it is. And then we'll get into 2 parts to the lab, two smaller parts for creating Express endpoints and using a RESTful API. The second point will be about, after you've done that, we'll be working with Express Router and using Express Generator, and template engines and things like that. So I'm going to talk for 20 minutes on Express. So we're just going to talk about, now we're going back to the back end. We're going to revisit Node as a web server, and we're going to talk about Express and middleware. So what is a web server and what's HTTP? So again, we're going back in time here to when we started talking about Socket.io. And basically we have this TCP/IP communication going back and forth, this protocol at the server layer. A couple interesting points about this is it was developed by the US military way back in the day, right? These 2 protocols, right? The beginning of the internet was created by the military, if you didn't know that. They actually have one of the original PCs still working on one of the bases, and it's a huge mainframe computer. It's actually still connected to the internet, to be honest. It's like the first computer to go online. You need 2 to be online in a network, but that was the first one they powered up. Anyhow, this protocol's originated there. So when we talk about IP, right, Internet Protocol, that's the concept of moving those packets between the nodes. Obviously, we said it's the foundation of the internet. So when we were using the sockets, the web sockets, we were on the bottom layer, and the HTTP request and browser and internet web requests are on top of that, right? So we were just dealing with packets, dealing with sockets, dealing with connections, right? We talked about all that. HTTP, of course, is what is the foundation of the internet, foundation of the web, hypertext protocol. Basically, that's the format of data being transferred over that underlying layer of TCP/IP, right? So we need both of those protocols to work, and we've already touched base with Socket.io and TCP/IP and all of those cool things you can do with that. Now we're going to deal with the next layer up. We talked about response headers, right? When you use your F12 and you were seeing exactly what was coming down the wire. When you have, and we'll get into that a little bit more, when you have the request, that payload that goes across the server, and the response, right? When we have TCP/IP in the socket, WebSocket, Socket.io, the payload in the request is very small, right? That's why it's so fast. Sometimes you have web applications that are making these big requests with a very heavy payload to get very small amounts of data, right? And we don't necessarily always want that. But this is what we'd be sending when the client sends a request to get our chat information for our application. We want to be able to respond with some data coming back in the payload and some header. The header may include status. We'll get to that in a second, like whether or not the response was okay, and maybe some information on that. So we get a status code. 200 is usually okay. Usually you'll see 404 not found. That's usually when something has been, some asset that you're looking for on the server is just not there, whether it be a page, web service, or whatnot. There's some more information in the header, especially the content type you want to look at. Text or HTML might be a page. JSON format, you might have different binary kind of things coming, but typically in the web, you're going to see HTML, you're going to see JavaScript and JSON. Maybe you'll see an image asset or something like that, some kind of static asset. Of course, the body tag is exactly what it sounds like. That is what is going to be used in your page, which if you're using JavaScript or React, would end up becoming the document object model, right? So some background on the get and post and get. So get is the method that sends the request. So you want to get something, right? So you're going to issue a get request, and basically post is when you are trying to post or send information. You're sending a payload. Guest is trying to retrieve a payload. Post is you're sending information via that transfer. You're posting a payload. Maybe you might get a payload back. That could be very true, but mostly you want to try to like persist some data, or you want to try to at least trigger something. something other than just a read-only, like a get request, maybe a read-only request. Whereas with your posting, you want to actually do something with that data. Maybe you want to trigger something else. So, and then there's other protocols as well. Sorry, other verbs for requests that you can get into, but payload usually can be the query string. It is the query string moved into the body of the message. So when we're talking about all of this, we were really getting at is what an API is. So when we're dealing with APIs, we're going to build one out today. API stands for Application Programming Interface, some type of interface that allows us to talk into a backend, that we can all sit back and understand the interface and how we may interact with it. We may not know the underlying techniques for how to retrieve data or whatever the interface does. We're just meeting in the middle. With API is a contract. It's basically a contract layer between client and server. If you want to get into these points, allows one piece of software to interact with another piece of software. Interface is made available on the web via a set of URLs. Okay, that's true. URLs can only accept and send data via those protocols that we talked about. So that's just a general kind of definition of what an API is. But when we get deeper into it, we start talking about endpoints. So endpoints, when we're talking about APIs, endpoints are one URL in a web API, and all these endpoints mean something, right? You may have a lot of endpoints. Say you have an API that's for banking, or you have an API, say, for, I don't know, something I use, I don't know, something like Stack Overflow. Say you have an API for that, or something for GitHub, right? When we were working with the JSON placeholder.tippy code, you have an endpoint to get all users, you have an endpoint to get one user, you have an endpoint to get all repositories. You know, all of these things mean something, and they can have many, many types of different endpoints that together compose an API. So these endpoints mean something, right? If you look at this protocol, this is a not secure, unsecure protocol. It's not HTTPS. We have the domain right here. We have our local host, which that's only for development, obviously. Then we start getting into like something, an endpoint, right? Here we have RESTful services that we'll talk about in a second, but usually have a context to what service we're calling. That can be, that can be anything. It can be a Google service, can be whatever service you're trying to connect to, right? And then you have, sometimes you may have a version, maybe not. And then you start digging into the different resources and parameters. For instance, I often use a ticket online inventory thing. I had to build a ticket site, and they have some ticket vendors or ticket stock, and they have a nice guide and API, and I actually will get all the event data and ticket data and all these types of things from their API, which is they sell obviously as a service, and it's quite a nice way to get external data into your site or application. But we've been talking about REST, and basically REST is this concept of representational state transfer. I can't even talk. Architectural style. So REST is a way of being, it's a very lightweight protocol. In the past, I've done web services that are heavier, right? Like they may, for instance, like in .NET, they have a whole series of web services that pass a different protocol called SOAP-based protocol. XML, very big payloads. They're very secure though, but it's in a format that is very hard for the web and very hard for mobile devices to consume. So they came up with this kind of RESTful database, RESTful API, and we'll get into what it returns. Obviously, it's in order for us and our purposes, it has to return JavaScript or JSON. That's what we're looking for, right? But getting back to REST, each HTTP verb and URL have a meaning. So if you look at that, we have a post, we have a delete, we have a get, we have a put. So now we can categorize our RESTful calls in that way. Delete is very, it's very self-explanatory when you're issuing a delete. You know exactly what the backend server is, where expectation is delete. I mean, we know that the server is not going to update something when we're sending delete, or we hope not, but we're pretty explicit in what we want to have happen, right? Put, you know, put and post, you know, they do, to be truly true to REST, you need to actually have update and create, but you know, developers often mix and match post. Post does a lot of things. Get request is pretty specific, right? We're just getting either, you know, we're issuing a read-only request, whereas put and delete and post are more, you know, they're modifying data. So we organize them in this way. And what makes the difference is the path. As you can see, this is all against the task path, but as we talked about with React and routing, you know, the differences in the path mean something now, you know. So if it may be possible to have, as we see here, a get request against task, but the difference is this one has an ID, so therefore it's going to go and get a specific task, whereas this one is for encompassing everything, which is not so different from MongoDB, right? When we do the find, the search, if we have no criteria in that find method, it returns everything. Otherwise, we have a filter to filter down. So that's what that is. This is just a little quick slide on, I don't know why I kept it in there, routing. So we want to have context of routing, mapping to a request to a content. So basically, we are going to start talking about Express Router, which again, you have context now of what a router is from working with React and our last lab. All right, so when we talk about Express, we want to get into middleware. So Express and middleware. We'll talk about the latter one after this. So Express for Node.js should be reviewed for you guys, I believe. If not, that's okay. So it's a very lightweight framework that's built to solve our problems of creating some kind of RESTful API for our Node.js server. So there's a whole bunch of words here, but basically that's what it means to do, right? It's built-in support for routing and HTTP handlers, session management, and one of the good things, it has a lot of middleware in there, which is really great, because then we can leverage NPM, and there's a whole bunch of things on there pre-written that we can tie into, which means you don't have to write it all yourself. And there's a lot of, and when we talk about middleware, we'll get to it in a bit, but you can download a package, for instance, called Body Parser. What Body Parser does is on a post request, it takes the message body of that request and parses it out really nicely for you, so you can then do something with it in the Node.js code, which is really great. Again, great community, all that stuff. Same like Node.js and NPM. Quick setup. Again, we're going to NPM. By the way, if you don't want to use NPM, you can use something called Yarn, Y-A-R-N. That is Facebook's version of NPM. It still goes to the registry, but it's a different installer. At one point in time, some people were saying that NPM was a little bit too slow, and maybe there's some issues with security. So Facebook created their own called Yarn that they say is a little bit more performant and has a little bit more security features. I think they're just getting in. Facebook's already into React. They're already into GraphQL, which GraphQL is a different version of this whole kind of API layer. It's quite interesting, to be honest. We'll talk about that a little bit later, but it doesn't deal with endpoints per se. It actually kind of turns it up on its head and does its own thing. So they're getting into a lot. So they also have a JavaScript bundler and packager, all that stuff, right? So Yarn's another way, but anyhow, for this example, we're saying npm install or I, and then express, and then we're saving that. Once we have that, it's going to go and download into our node modules. Again, we do the tried and true require. Once we get express, we wire it up as an app. We instantiate it, and then we basically have it listen right on our port, the same port that the server started on, the same port that could be listening on for your socket.io. Basically, you're adding another layer to be used, right? So we already talked about this already, but once we install Express, now we have access to all of these types of methods and verbs, as we already talked about: get, post, put, delete. Get is supposed to be for fetching, post adds new data, put updates, delete deletes. Again, the line gets blurred between post and put a lot, to be honest, but just know that to have a truly good RESTful API, There's all types of criteria, what makes a very good RESTful API, and that would be put and post or actually doing their own. They have their own separation of concerns. They each do their own, but just know that everybody uses post a lot, to be honest. So again, quickly how to set it up. Number one, you use the Express module, you include it in. Number two, you create that object of the Express module, and then you start to create your endpoints, right? Now this is a very basic example because we get into the concept of a router later on, but this is something that you could quickly set up, that if somebody just does slash, it's gonna return back a message in the response. Again, you can return a file, you can return a lot more in the body, but for a basic level, this is how you set it up. Again, it's how many lines here, like 10 lines of code, and you have a RESTful API, very basic, that you could use. If you're not impressed by that, go look at the code that was required to build a node server. Again, it's all JavaScript that gets compiled down to C++, compiled down to machine level code. So there's a lot more going on than this, but just know in JavaScript that in a few lines of code, you have an API, HTTP server ready to take web requests, which is really great. So that's what we need to do. So when we're defining routes, so Express can respond to all these HTTP verbs we talked about and that API methods. A route can have the same name as we talked about, but we can handle it a little differently as long as, you know, there are some other attributes to it. So a simple example of setting it up, again, I should use my laser. I have a laser here. Why not? Bar Express. See, you could see this is old school kind of JavaScript here, but you know better, right? You could set that. It's probably better to set that as a constant. But a lot of, like we said, a lot of the JavaScript you'll see is precursor to ES6. But we know better, right? This would be a constant instance of the Express. We don't want it to be overwritten anywhere. And then we set up our endpoints. So this is the slash, render the home page. We have a content. So if somebody is entering this in the URL, you know, we're rendering these different pages. And again, at the bottom there, I have this hover, sorry, it's /user/user ID. And again, same as in React. If you want to actually have a parameter, you use those colons, right? Colon user ID. And then of course you have a functional callback, and then that says go and get the user page for a particular user. All right, I think we're more than halfway there, so bear with me. Just bear with me here. We'll wrap this up and we'll talk about the labs. So routing paths. Actually, you guys should be good. I haven't actually done this before. I haven't actually done a live lecture, so they've all been in videos. So you guys have been lucky, maybe. You could actually fast forward me, but you can't right now, so you have to listen. So routing paths. So basically, like we said, we can build our routes out. Express is actually very expressive. So you can actually do a lot with this. You can have a lot of, as you can see in these two examples here, there's a lot of different kind of matching you can do. And you can actually have some wild carding in there. It doesn't have to be just a straight, like, you know, straight slash, you know, I don't know, players, right? You could have player and then can match many other routes. So if somebody's typing in the URL, if somebody happens to be, you know, misspell it, you can kind of do some checks against that to actually catch those different calls, right? So you can actually add regex. If you don't know what regex is, there's a whole bunch of this kind of thing going on here, where we have star and $, these kind of things, and you can actually so this path right here in this regex will match. There's fly, and that will actually determine that anything in front of it will be wildcard. So you can see butterfly, dragonfly, whatever. And also at the end here, it'll match anything after that, right? Whereas this one over here is kind of concatenating, where you can see the different matching. To be honest, I need to read over this stuff sometimes, because regex is always something I always need to look back up, because the regular expressions can get very crazy, to be honest. You can match a lot of things, but if you ever look at like an email address regex, regular expression, is quite long, and it basically covers every scenario. You know, it needs to have an @ sign. It needs to have no non-numeric characters. It needs to have, you know, only allow uppercase and lower. Like, there's a whole bunch of things you could get into. It's very powerful, but like I always have to refer back to the guidelines. So there's something on matching utilities in there, and we're going to do that in our first portion of the lab. All right, so route parameters, as we said, you know, these parameters are the URL segments, and we can capture different values and their position in the URL. And it all comes in this REQ, which is the request parameter object. So we have a route path /users. Let me use my laser. And then we start getting into the parameters, user ID. Then we have another /books, and then like this is kind of a multi-route kind of route. I mean, multi-attribute route path. So you can encompass this kind of thing. So you can have users, and we know this is a parameter 34, books, and this is another one, and we can match it up in this way. So on that callback, if we say request.params, it's going to give us a JSON object that has information on our request, which is really great. And of course, here's a way of using it here. We have a callback. We just send back the parameters. So it's an easy way of parsing that information and then actually inspecting it. You know, you can do your logic off of that. You know, I need to go and query from MongoDB this user, and then I need to go and query that book, right? And you can do things with that. So that's route paths. Handlers, of course, we provide multiple callback functions that behave like middleware to handle a request. All right, so what that means is we're basically adding our own logic, and we can actually use something in a way middleware. Like we can execute callbacks, and we use something called next, and we'll get into middleware what that does. But you can bypass the remaining route callbacks. So you can kind of create your own middleware, and middleware, we'll get into that concept in a bit, but just know that when we're talking about middleware, there's something called next, and that's going to be very important in a few slides. But just see this signature here is a little bit different than a normal signature, because the normal signature is request and response. So in a way, we're kind of hijacking the call before it gets to the call that it's meant to be. And we'll get into why that happens in a second. So continuing on with route handlers, an array of callback functions can also handle a route. So we're talking about middleware in a little bit earlier here. So we can actually have a callback, and again, this next, basically what it does is once this is completed, it goes to the next call, and it'll go to this one, and then when you trigger next, it'll go to the next call. So you can actually, in your GET request, have an array at the bottom there to say something like like we have that .all, promise.all. These all need to be completed until we move on to the real request. So in a way, that next is very important, and I'll tell you why in a little bit. So response methods, these are, you know, this is in the documentation. I encourage you to use the Express.js documentation. It's very good. As you know, like always refer back to your documentation. On that response object to the client, there is these main things: download.json, redirect, render, send, all these type of things. But just know that you need to send back a res.end in order to end the process. If you don't send that res.end, it's going to actually, it'll hang up. Your request will, your client will never get a response, and in a way, it's going to be just idle. Not idle, it's going to be pending. It's going to be stuck in a way. You need to end the request response. Otherwise, it's basically like calling out and never getting a response back when it's expecting a response. So that res.end is very important. So middleware. All right, so this is what we were trying to talk about before with that next. So this is really cool. This is a part that code sits between the layers of the software. So when that request comes in, you can actually middleware in the middle before that hits the server, before you can actually do it on the request. So when the request coming in, before it hits the server, you can actually put some layers of middleware code inside of there. So if you have a security middleware, maybe that security middleware does something like, you know, it encrypts something, or it checks that the request has a JWT token, which is security, meaning that maybe somebody's logged into our application and now he has a token with his response, his request, right? And we're only going to handle incoming requests that have that token or that kind of authenticated logic, right? If he doesn't have that, then our routes are protected. That means that he automatically gets rejected in his request. He doesn't even hit the server. So that's a very good piece of work, and there's a lot of other ones inside of there. As we talked about body parser, we can parse things before it hits the server. There's cryptology, there's a whole bunch of things, logging, right? We said logging, like you could log every request coming in. At the same point in time, the outgoing request, which could be the response, we can also, in between, before it hits the client, do a bunch of stuff on the way out. In a way, it's kind of like, if you haven't done Angular, but other languages and other kind of services have a concept of interceptor. So it's a way of like you're intercepting the call before it hits the server or hits the client. You're intercepting that, and then you're doing something with it. So, but each one, as you notice here, security, routing, logging, if they don't have next, that next keyword, it gets stuck there. And basically the request doesn't go any farther than that. So that keyword next is very important because it allows the flow to go to the next middleware and then the next one and then to the server. So again, there's some housekeeping you need to do. Otherwise, your requests and responses will not flow the way you want them to flow. So we can look at middleware as that pipeline. So it's a pipeline that gets called before your handler, your request handler, or on the outgoing one. So express applications are basically a bunch of middleware calls. So hence, way back when we were writing our own custom middleware, that's why that when you include express, you have access to that next keyword. So to read the verbiage here, middleware can execute code, make changes to the request and the response objects and the request response cycle, and then call into the next, again, keyword next, middleware in the stack. And then here's another little example of what it does here. So here's our request. We have request and response logging. We go next, user authentication. Maybe it's some kind of some other third-party auth. Maybe you need to authenticate. Do some kind of parsing. Static files, routing. So you're actually routing the page before you even hit the HTTP response. So this is kind of the flow. So middleware is a function with access to the request object, REQ. The response object is RES. And next has access to the next middleware object, next in line in that cycle in Express. So this is giving you an extra layer of abstraction that Node.js does not give you. When you can easily, as we looked at, when you launch a server and then respond back with some kind of static page. But here it gives us another layer of abstraction to do a bunch of things and manipulate those requests coming in on that protocol. So a couple modules that you might want to grab, some really nice modules, middleware, again, obviously third party can be found here, but some really popular ones that I forgot to mention is cookie parser. So that's a really useful one if you want to inspect the cookie data, the header. It has a whole bunch of nice little features where you can start to parse it and inspect it, and maybe you want to do something with some of the information in there. Of course, the body parser is which we use quite a bit. For the request body, it parses it out, gives you all the information in a nice JSON object. Passport.js is really nice to use if you want to authenticate, do some authentication. I know in the bonus section of the assignment, I had an admin login. So you would be using Passport if you so wanted to. There are other middlewares out there, but Passport.js is a good one. It allows some authentication, key token, token generation and those kind of things. And you can actually protect your routes also to make sure that your routes are secure and all those kind of things. Once you get into security is a whole other topic, right? It's another lecture entirely. There's lots and lots of things that we can talk about. With security, right now we're just kind of glossing over it, to be honest, but just know there's a lot to it. But I descoped it, so unless you're interested, you can do that. But for our assignment, it's not really required right now. So static files, you may have seen this already, but when you have Express, you can use express.static, and it will actually look in your it'll look in your directory and try to find out if there's some kind of page to serve up. So to serve static files such as images, CSS files, JavaScript files, you use express.static, which is built-in middleware in Express. So what it does is that signature, express.static, root, and then some options. Root is the root directory from where to serve those static assets. For example, to serve images, CSS, JavaScript from the public directory, this is how you point Express to it. So you point it there, and then it can actually return some of these files in the response. All right. So second part of our lab, we'll get to that in a bit, but we're going to talk about the router, because we have now been kind of manually building some routes, but we have the concept of a router, which you should be familiar with because we've already done routing last class. Actually, it actually worked out good, to be honest. And then we have something called a generator, which is really, really nice as well. So the Express router is what you would expect it to do. So we use this router class to create the modular mountable route handler. So we can actually organize our files in a way, especially if we have a lot, we can create different route handlers to handle different portions of the routes, if that makes any sense. So in our example, if we were doing a chat application, we could put it all in the app.js or server.js, but that file can grow to like 5,000 lines or 2,000 lines of code. It's better to try to pull out the pieces of the code into very organized design and architecture, right? So you could create a router folder, and then you have a chat router, and you have an event log router. And within those files are all of the routes that deal with your chat history or your event log history. So you might say something like get all events, create a new event, delete an event, those kind of things. Same thing with the chat. You could say get all chat history, get chat history by user, delete all chat history, all these type of things. You could build out a whole CRUD application, which means create, update, delete. You could have a whole admin that actually modifies data and all of those things, right? But you would do it in a modular way. So a router instance is a complete middleware and routing system. For this reason, it often referred to as a mini application. So you can see when you create the Express object on it, there is a express.router. Once you have the router, you can then start to add your own middleware to it, to be honest. You can actually, if you see here, you're creating a time log. So you are actually on every route. You can actually console log out and then use next. So you're hijacking the all requests, and you are basically passing it through. So you can add your custom middleware in that pipeline. You just have to remember to trigger the next to go to the next one, otherwise it will be hung up. So if we want to use the Express router, which we will, we load it up as we did up here, and then we start to define our route. So here's a basic home route that has a callback, nothing really fancy there. And then we have another /about. So this, and then we do something, we send back the about birds or whatever. And then we basically export this out. We export this out, so that's a module. And now if we want to include this, by the way, this is the birds router, the birds.js. So we can require it in. And then how we use it is we say, okay, /birds. Now /birds, we'll use this router. Anything that comes in the URL has /birds. Now it's going to go through and hit all of these points. So you can do /birds will be the default. If it's /birds/about, it's going to trigger into this. So it's a way of organizing our routes in a very, very nice way. Separation of concerns, separating out all routes that basically pertain to the URL for the action you want to take, right? Like I said before, you could have all these routes inside of server.js, and that grows really fast, and it gets very unmaintainable, and it gets very unusable, to be honest. This is a way of organizing your code. And then obviously, you know, there's a lot more to it. Once you use the router, you can do a lot more things. Express generator is something we'll look at quickly. It's really nice. If you have no idea how to use routers, if you have no idea how to set up, you can actually run Express install. You download Express generator for NPM, and then you go ahead and kick that off, and it will scaffold out an entire application for you that has all the routes kind of. Now, when I mean entire application, I mean, you know, a pretty basic one, but it shows you how to really organize. It gives you a nice skeleton of what a Node.js Express site would look like, and it's actually quite nice. And you can use that, and then we'll get into a concept of, and you may not have done this, you may have, I don't know, template engines. So this might be interesting in the sense that you may not need to know a UI framework. In the past, obviously, all the UI was done on the server side, especially like Java or .NET. You know, web forms and MVC and these kind of things, they were all generated server side. And server side, they would generate, you know, the payload would go exactly to the whole payload would go to the client. That's how these things worked before. You know, you issue a request for a page to the server. The server goes and generates the HTML on the server side. The server then passes that huge payload to the client every single time. It's a lot of traffic going on. It's fast though, it can be very fast. So in a way, you could build an entire application with just Express, Node.js, and Mongo. So just remember that. If you are good at backend Node.js, you can build an application just with Node.js and Express. You don't need a UI framework. So UI framework adds a lot more to it, a lot more interaction, a lot more speed, but you can still build a pretty quick and dirty application with just this that looks pretty good. So a template engine allows you to use static files in your application. At runtime, this template engine replaces all the values and it generates HTML. So there's a couple things you can use with Express. There's one called Pug. I love these names, right? Pug, Mustache. There's one called Jade, right? The default one's called Jade, and there's EJS. And you can do npm install, and you basically check the template engine you want, and then you can use it inside of your engine. So what will happen is if you get a request, Node.js will, using one of these template engines, generate the HTML and fill it in and return it back to the client without any framework in the front end, that being Angular, that being React, or any of these things. But just know that if you have an API, which we've been talking about, actually this is the last slide. So if you have an API, it allows you so much more flexibility because you're, you know, here when you write an application, and I've seen it many times with web forms or something like that, you put all your logic in something like a server-side code. It's hard to rewrite it and hard to refactor it. If you create your logic in a RESTful endpoint, then the UI there can be multiple UIs. There can be a React UI. There could be, you know, version 1 and version 2. You could have somebody coming to you and saying, okay, I want to connect my mobile device to your application. Maybe I have a backend service that wants the one. So when you do software as a service, which is called SaaS, software as a service, all the software and logic is encompassed inside of a service, exposed, and then it doesn't matter what the UI is. The UI can be anything. The UI can be a desktop, it can be anything, mobile, you know, tablet, web-based, or it could be another service itself. And then it can be any technology, because now we're dealing with a very common generic interface and a very common generic return type, which is JSON. And then the flexibility is whatever interface or technology that may want to consume it in that fashion. So you can use that for years, to be honest, without having to refactor a lot. So anyhow, that's my soapbox here on Express. So I'm going to stop sharing. That went a lot longer than I thought. So I'm just going to somehow stop recording here. And